Okay, so we're gonna talk about scope of the variables. This is CSC201 class, and we're gonna talk about this, the keyword this, and we're gonna get into thinking as object, right? In terms of objects. All right, so let's look at the scope of your variables that you declare. So it's very important to understand, right, the scope of instant and static variables in the class, and regardless where it's being declared. Again, instance and static variables in a class are referred to as class variables or data fields. Like example here. So we see these are the class variables I and j, right? And also let's look at this one, radius also, right? So the scope of a variable defined inside a method is referred to as a local variable. So let's see, do we have any method? No, we don't have any local variables here, right? But this is the local variables here, x equals to 1, right? Because inside the method, it's going to be valid locally inside the p method only. So the scope of a class variables in the entire class, regardless of where the variables are declared. Like you can declare the bottom is still valid inside a find area method like that, because the radius is a class variables or the data field. You may declare later, right? Regardless of where it's declared. It can be any order in the class. So the exception is when the data field is initialized based on a reference to another data field. In such cases, the other data field must be declared first, like in this example. Like if you try to declare like private int j equals to I plus 1 first, that's not going to work because we don't know what's I. So you need to declare I first. Right, exception for that. You can declare a class variables only once, but you can declare the same variable name in the method many times. In different non-nesting blocks. Okay, so let's look at this program. If a local variable, like this is a local variable, has the same name, x, as the instance variable, the local variables will take precedence, and the class variables will be hidden. So let's look at this program. What is the output of f.p? When f is an instance of f class. So in this case, since it's taking x local variables as a precedence, so this x should be 1, not 0, even it's the same name. And y should be equal to 0 because y is the instance variables here. So to avoid confusion and mistakes, do not use the names of instance or static variables as local variable names, except the method parameters. You know that we like to use the same name for the method parameters because we're going to use this reference to refer to the object or the local, the class variables like that. So this refers to the object itself. Like when I said this, that means refer to the circle. Then that's why we do dot. You refer to the method or data fields. Like in this case, this refers to the circle object. And dot radius just refer to, just like when you use dot operators, right? When you have instance variables, you use dot, right? To refer to the method or the attributes. So this is how you refer to the data fields of the class dot radius. Okay, besides that, you can use these variables inside a constructor to invoke another constructor of the same class. This one they use this .getArea to call this getArea. So let's see an example of this. To invoke a constructor right there. Like I have two constructors in the circle class, and one constructor taking the radius, right? And like I said, this is very common. We want to name it the same, right? For the parameters and the data field. And this refers to the circle reference to the radius of the data field of the circle. And you pretty much just set the initial values to radius. Now, the second circle constructor, actually, we want to keep the default value to 1 when the constructor being called and never pass the radius. So we could just use the this to refer to the constructor itself that has the radius parameter by passing 1 to it. Okay, so we use this to invoke another constructor. All right, so what's wrong with the following code here? Class test private int ID. So this is pretty much just practice for your test. You're gonna have something like that in your test.
So ID is a private variable, so can you?
Does the test refers to set memory space?
Is there anything wrong with this? So this refers to the data field ID, but the data field ID is not a static field, right? Then you cannot use the class name, right? This is the way that you do this, is refer to statics, right? And this is non-static, you cannot do that. So we can test that. So there's a problem right here, right? Non-static field ID cannot be referenced from a static context, because when you do that, you try to refer as static. We talked about that last class. Okay. So all the questions at the end, like checkpoints here, this is things that you want to review to prepare for your test. I'm not going to cover everything, okay? All right, so let's talk about object-oriented thinking. So thinking in terms of object. We want to do this to apply class abstraction to develop software, to explore the differences between the procedural paradigm and object-oriented paradigm, to discover the relationship between classes, to design program using the object-oriented paradigm. And we also want to talk about wrapper classes. Those are classes that refer to the primitive data types like byte, short, integer, long, float, double characters, and boolean. To simplify programming using automatic conversion between primitive types and wrapper class, we call box and unbox, boxing and unboxing. And we talk about big integers and big decimal classes for the large numbers with arbitrary precisions. And we talk about the differences between string class, string builder, and string buffer. So the difference for sure is string is immutable, and string builder and string buffer, they are mutable. So immutable means once you create the object, you cannot change it. For the string, you cannot change. Like string builder and string buffer pretty much technically define the string just like the way that you use string class. But the object that created from these classes, it can be changed. I will talk about that. So first we want to look at the differences between procedural programming and object-oriented programming. So we have learned how to create an instance of the object, right? From like classes like circle, date, random, scanner, point2d, and so on. Those are classes in the API, Java API, Java Application Program Interface, right? So this chapter shows how procedural and object-oriented programming differ. You see the benefit of object-oriented programming, how it's more effective than using the procedural programming. So class abstraction and encapsulation. So what abstraction? So abstraction try to separate the class implementation from the use of a class. Like for example, you can look at a class like a black box here. And client use the classes through the contract of the class. So we have the contract, which is the signature of public method and public constants. Signatures meaning those parameters. Like for example, we use scanner class. It's a black box. You only want to read in the integer, you just do .next int. You want to read string, you just do .next. Which you don't really need to understand how the class is implemented. How does that method being implemented, right? You only need to learn how to use the class. So the class, pretty much known as ADT, stands for abstract data type. So the details of implementation are encapsulated and hidden from the user, and this is called encapsulation. So let's look at some of the real-life example. Your personal computer. So inside your computer, you're gonna see they have CPU, memory disk, motherboard, fan, and so on. So each component can be viewed as an object. You need to know how to use it, but you don't need to know how the components work internally. And internal implementation is encapsulated and hidden from you. You can pretty much just build a new computer without knowing how a component is implemented. You can just put them all together. So the same thing in object-oriented programming approaches. It's the same approach that we're looking at. So for example, you might have a class that models all kinds of fans for use in the computer with properties such as fan size, speed, and the methods such as start and stop. A specific fan is an instance of this class with specific property values. So another example could be a loan. So you create a loan class that has interest rates, loan amount, loan period. And then you have the method to compute like the payment, monthly payment, total payment. And then when you start to buy a car loan, so the object is created by instantiating the class with your loan interest rate, right? So if you look at the relationship on this one, I'm just going to use this tool for drawing. So you pretty much just going to create an object of the loan. So this is a loan class that has the data fields, annual interest rates, number of years, loan amount, and loan date. And then you create an object through the constructors, and you have the method getters and setters. So technically, when you want to invoke or create an application for car loan, you pretty much is going to rely on a loan class. All right, so this is pretty much an object of a class, right? So let me create a rectangle. Shapes. And then the object is pretty much a loan, right? So this is represent the whole class, a loan class, and it's in a black box. So you don't have to worry about how to implementing it. So the only thing that you learn is I'm going to create an object of this. All right, so I'm going to create an object. So when you pretty much just get a car loan, so this could be an object of the car loan. So car loan, which is an instance of the loan. So we just do loan, car loan equals to new loan, right? By calling a constructor. That's what we just need to learn. Now car loan pretty much is going to involve all the methods that loan has, like get monthly payment, or get number of years, get annual interest rate, get loan amount, get loan date. So this is pretty much just, you just learn how to use the loan object, but you don't need to worry about how it's being implemented. So it's encapsulated in a black box. But car loan itself is going to use the loan. Like if you happen to have another object, you could just create from the loan again. Right, and another object could be, if it's loan, you may say, okay, it could be like a home loan, or they call mortgage, right? And this object technically could just create from the loan class. But if you look at this, it's pretty much technically, you could have the loan as the parent, and then you could have the car loan extends from loan, and home loan extends from loan, and car loan and home loan itself can be another two objects, right? Two classes. That if we talk about when you go to Toyota leasing could be another object that creating from car loan. Right, so this too is going to create from the car loan. So sorry, I'm not really drawing with a pencil is nice, but that's what I try to create here, right? And then if you talk about, like, if you go to another listing, like maybe Nissan's listing, that's another object. So you can see that objects just create from another class, and the class itself create from another class. So this is called inheritance here. Inheritance relationships here, right? If you think term of objects. And of course we talk about small system here, right? Like car loan, maybe only use loan inside it. But we talk about bigger system, like if you talk about car could composes of wheels, tires, and wheels, tires, those are another objects. All right. Now this is pretty much just a main. A main pretty much just, it could be, this one just named test loan class. Like I said, this could technically be a Toyota leasing that start to prompt the user with enter annual interest rate, for example. It depends on your credit score, so it can be 8.25%. And then depends on how many years of the loan you want to do, number of years, 5 years, 3 years, right? And then it depends on how much loan you want, right? So 10,000, 20,000, right? And then once we get that initial values, since we want to create a loan, we ask user for unknown values like the interest rate, which is based on your credit score, the amount that you want to loan, and the number of years that you want to pay back. Then we can start to create an object of the loan. Okay. And then after the object is created, you technically can just use the method of the loan right away. You don't have to know how to implement the loan itself, right? Because it's a black box and abstract to you. You can say get the loan date, get monthly payment, because that's going to calculate for you. And then get the total payment. That's just an example of loan class that has been implemented. So thinking in objects. So the procedural paradigm focuses on designing methods. The object-oriented paradigm concepts data and methods together into objects. So software design using the object-oriented paradigm focuses on object and operations on objects. So this is just another example. It said, I want to create a class named BMI. BMI stands for Body Mass Index, right? So if you see, when I create BMI, I have attributes name, age, weight, height, constructor BMI, get BMI, and get status. So once I create this object, it makes it more reusable, right? So I can just create an object of BMI 1 and object of BMI 2 based on each user, name, age, weight, and height. According to that, then we can just calculate and get the BMI. right? Get body mass index and get the status. Like status could be, we can tell that if this person is normal or obesity based on the BMI, which is based on the height, weight, and age, right? That they use it for calculation. So this is thing in terms of object. You can see that we can reuse this object over and over again. So reusability is the key on object-oriented programming. Alright, so now let's look at class relationships. So we were talking about that last time already. The association, right? So if we have to review this again, we have student take courses, faculty teach courses. So this is going to be associated between classes. So we were talking about this relationship in the term of aggregating and composition. So aggregation has a relationship. The owner object is called an aggregating object and its class is called an aggregating class. So let's say we said composition means it's only one, right? And belongs to the student, which is name. But aggregating means it can be shared, right? Like address can be shared among students. So that aggregating. And both of them has a relationship, like student has a name, student has an address. Alright. We were talking about this last time already. So this is just showing the review. So let's look at, if I want you to design a class for stacks. Stack is pretty much just a stack of books, stack of shirts, right? So this is a type of data corrections or data structure. Like if I want to collect the data, I could have it put into the stack. Like example is the file system. Like in Microsoft Word, we can, when you open it, it's going to stack all the recently file that you open it on the left, right? Like all the file that you use, you want to reopen it. Like for example, these are the stack, right? It's on the left hand here. If I open a new one, it's going to create a new stack. I mean, it's going to push, it's the same stack, it's not creating a new stack, but it's going to push this file onto the stack. Like it's push the data one like that, but it's going to push the test file onto the stack. So this is just an example of application of stack. Like if I go back to Word again, you see that it's pushed into the stack. And it could have so many stacks. This could be a stack of today, stack of yesterday, stack of this week. Just like that, like stack. We push, 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 push. And the recently opened just going to be on the top. That's pretty much an application of stack. And then once I open it, it's just open it, or I can just remove the data in the stack. Now, since we know it's stacked, And we know that this could be implemented in terms of, we talk about what, objects or thinking, right? So we want to be able to reuse stack in any applications like Excel, Word, PowerPoint. They can be, right, I can implement just once and reuse them. Right, that's the point of object thinking. And you don't really need to be the one who implementing it. You could have someone in the team, Microsoft team, implement the stack for this feature. And then another programmer just integrate back into the Word document, right? Another programmer doesn't need to know how he implement his stack, right? But he just know that how to use it, that's it. It's like black box, right? So how would you design a stack class then? If you were asked to design this, now you know what we need at the operations. So first, you're going to design a UML diagram, say stack. And stack is a collection. So if you design, say, we call it elements. Element is pretty much, in this case, example of the file, it's going to be file as an object. So that means it should be an array of object if we want to. And this one, it could look like this stack. So I create an array of object, and this is a stack class. So initialize the size equals to -1, meaning when you start, if I say 0, then there's an element, right? Here in index 0. So we're going to have an empty stack when we start. Just like an empty stack like that. So this is a constructor, just an empty constructor, just create an empty stack. Size equals to -1, that means the stack is empty. Now I start to design the operation of stack, like I pushed every time, right? I want to push an element, so I just call element that I want to push, pass into the method, and just assign that to an array, right? And the size is -1, so that's why I have to assign it to index 0 by size ++. So every time I call this operation, the stack is going to increment my array, and I just limit to 10 for the stack, the size of the stack. The object, I just say 10 here, right? Because the array size is 10. Now whenever I want to remove it, I just call pop. So this pretty much is common operation of stack, push and pop. Push just to add into stack. Pop is just to remove from the stack. So how do we remove? Pretty much just I need to return the size. Pretty much this is the data field, so it's keep tracking the latest, right, index. So return back the item into the temp, and this is an object. And then this part pretty much just set that location to null because we remove it, and then reduce the size and return the object that we pop out. And stack also have another operation in case you don't want to remove, but you want to just open the recent one on the top or see what's at the top. So we just have the top operators to return the list size, just telling you what's at the top of the stack. And we have the operation to get the size. But let's just go to returns the size of the stack, like how many elements we have so far, which is the index itself +1. And toString pretty much just return all the contents of the stack. So if I want to test this stack, I pretty much just write a unit test, right? This is pretty much using the stack now. So create an object of the integer stack. Start to push the numbers into the stack, number loop 1 to 10. And now we want to print the elements in the stack. And then that's just try to test. We just test the size to see if this stack is working. So we expect to have 10 elements because we push 10. So it should be, assert should be equals, then it's going to be green and returns true. So this is just showing the list of stack, number 1 to 10 to the top. And its assert is true, the size 10. So that's how you pretty much just design class for the stack. And I just show you in the real code, right? And then you can just pretty much use that with any application that you need for stack. Like this one, technically can use in the file system already, right? But because an object could be any type, it could be a file type by passing through the parameter here when you instantiate it. And this topic we call generates, so you're gonna see it okay soon. But this time, that's why keep in mind that this stack that you see here did not talk about any type yet. That's why I just give it to integer for now, because you didn't get a chance to learn how to make it support any size. I mean any types. This is only integer types. So this is just how they implement the stack. Peak is just like top. Look at the top element. So for this one, it's just a little bit different than mine. This one is just showing they just create a default as capacity, and when they create a constructor, you can just initialize your size to whatever size that you define. Otherwise, it's going to be default to 16. And this one just create an array of elements and give it a size. But this is going to support the integer only. And this one, whenever you push, check to make sure that you're not going to really overflow the stack size. Because if it's size greater than the length, then you technically want to, this one is pretty much just enlarging you just create a new array with double the size. Like the one I implement is always fixed to 10. Right, this one actually you can enlarging it. You create new elements and then you copy the array, the old one to the new one. So meaning that this stack can be dynamically increasing on size. And then just assign the value to the elements. That way. Like mine that I created, I didn't have it dynamically increasing the size. Just a simple one. Okay. Push and pop. Technically, yeah, I can modify it to be short like that too, in one line, by decrement first and return elements. It's good to return elements and then decrement the size. And this is peak. So this is just return true if the size 0 was empty. This is get the size of stack. Alright, so that's pretty much an application of how you create an object. Now let's talk about a wrapper class. So what's a wrapper class again? Like a class that represents the primitive data type, like an integer class, double class. So the common data fields that we see is the value. We have two constants, the max value and the mean value for the integer, which is 2 to the power of 31, right? 31 minus 1 for the max. And the mean is negative 2 to the power of 31. And we have the constructors. You could create the object of integers from string or from integer. As well as double is the same thing. You can get a byte value, short value, int value, long value, float value, double value of the integer itself. You can just pretty much just can, like you casting into different data type through this. Like you can change integer to short, float, double, byte, and you have compare to. Compared to, we already know that square returns negative, positive, or 0 when it's equal. Negative is less than, positive is greater than. And then we have toString version, meaning that you can just convert from integer to string with this method. We can get the value of the string, return the integers. Now, the good thing about the value of radix means you could convert into any radix point. That means like hexadecimal, decimal, binary, octa, like any number base. Okay. Just like the calculator that you use for Microsoft here, you could convert into hexadecimal, decimal. Technically, you just use the here integer dot value of and pass a radix point in. That's how you write that application. And we already know parsed int, just convert integer to string. Like the value of just string to integer, right? That's the opposite. And we have parse int for the radix too. So that happened the same to all other methods like double, float. For the wrapper class, they're pretty much the same thing. So this is just showing you how to use them. Like this is parsed to the radix like 11, right? 1 1. Actually, you say this is the radix 2, right? So 1 1 base 2 actually is decimal is 3, right? So let's just do binary to decimal conversion. Like 1a base 16 is technically just 26 in base 10. Like you can check again. If I say 1 plus a is 26 in base 10 right there, right? So that's how you use the parse in with the radix to convert between hexadecimal to decimal and so on. So technically you just need to know this for your test. If I ask you to convert, then you know what to do, right? It's just a lot of things that if you never use, you pretty much not going to be able to do it. So that's why in your class exercise it's going to help to practice using this. You also have the big integer and big decimal, right? So that's to represent the number with any sizes. Because we know that if you use double itself, that's going to be a limit. Integer itself is going to be a limit because it has min and max. But for big integer, you can have any sizes and any precision, like this dot. right after the decimal point you can have any size of that, long, very long like that. So then you can just calculate like 50 factorial. So if you just use this for long, it's not going to be enough either, right? So that's why big decimal and big integers come to help. So we talk about string class. String class is immutable, meaning you cannot change the contents. And it's true, you cannot change the contents. Like for example, like this one, you can see it's going to be on your test, and a lot of you may be confusing and fail the test because of that. Like if I ask you, I have string name equals to tennis. So it said this is immutable. You cannot change tennis anymore. So if I do system.out.print name, I have to put in public, right? Statics void. So this will print tennis, right? Now, how do you change the string? How do you change the string values? How do you change the name?
You assign new value to it.
Okay, is it to uppercase? Yes, I can convert to uppercase, right? Correct? You think when I print it is going to change to uppercase? Hmm? How many of you say yes? So how many of you say no? Okay. It never changed to uppercase because it's immutable. Once you create, you cannot change it. It actually returns a new object. Right? It's actually create a new object, it returns. Like the original value is still there. See that? Few of you failed the test already. You don't understand this concept, right? So this is means string is immutable. Alright, so we also talk about string builder. It's pretty much just a class again, right? So you know that string itself is a class. You could just do new string, it's the same thing, but it just make it shorter by you can remove that, right? The new and string constructor. For string builder, yeah, you pretty much have to call the constructor to create that. So I have string builder, right, for last name. So there's a string is immutable, string builder and string buffers are mutable. Immutable means cannot change, mutable means you could change. So how do you change this? You can get the methods. Let's find the method. These are the method of string builder. You can delete a char, add in index. You can do insert. You can replace. You can reverse. String you cannot reverse, huh? You could do two string. I wonder, do they have two? They have two uppercase, otherwise we would test it's the same. But let's test something like replaced. So now I'm going to do the same thing with replace here, right? Because they have replaced too. See that? You could replace all characters, let's say T, with the new characters P. So if I run that, you think the name is going to change to P? How many of you say it's going to be from tennis to panis? From tennis to pan? Huh? We are doing the same thing. We're going to replace with. Now, the method itself could be different to use because it's pretty much different class. Say you can replace at the start index and end at the end index with the string that you want to replace. Now, if I want to do one letter, pretty much start is 0, right? Line array, right? End at 1, and the letter P replaced. Instead of saying what letter to replace, you just say what index to replace. Just replace that, right? All right, so now I'm going to do the same. Print so you see this, since this is immutable, you cannot change 10 as it's still the same. But you could return a new object string which is upper name that replace pants, right? But string builder is mutable. When you replace, it change the original one. It's not keep. So that's the difference. Now you understand the immutable and mutable concept. So that's why sometimes we want to use string builder instead of string when you actually want it to be mutable. All right. So what about string buffer then? String buffer, technically, everything is exactly the same as string builder. The method is also mutable, the same thing. Everything is the same. It's doing the same, using the same method. The method name are the same. The way you use is also the same, but that's one thing that's different. So one is good for concurrency, and one is not good for concurrency. So what's concurrency? Threading, multitasking, processing. Like for example, since it is multiple, right? If I create a name, like I create my account, I sign up, and then I want to update my contact numbers, my address, and they are using their string type, right? Right, address dot string. I want to update my address. So if the application running on my PC alone, that's fine, right? But if the application is not running alone on my PC, and meaning that it's supporting concurrency or multi, right? Meaning like online, you can sign up, you can log in, you can edit, update at the same time. Like let's say you happen to have your address change and you try to change the address, update, but one of your family member try to do it at the same time. So you update from A street to B street, and your family member try to do it at the same time. So what happens? It's just like when you go to intersection, you try to run through the light at the same time. What happens? Right? So that's why one actually support when someone is trying to update, it's going to stop another one try to access and update. Just like we have the traffic light going on right there, stop sign going on. So string buffer is the one that support concurrency. We're talking about that. Here's string builder, string buffer. They're similar. String class is immutable. Like string buffer, string builder, they're similar to string too. And these are the methods that you can use to modify the string. Now, so what's the difference between string builder and string buffer? Now you understand the answer for that, right? Concurrency, right? Let's see if they talk about it here. Concurrent programming will be introduced in chapter 30. Okay. So string builder class is similar to string buffer, except that the method for modifying the buffer in string buffer are synchronized. So that's a difference. So the methods like replaced that we used, they are synchronized. So that's a keyword, synchronized. Synchronized mean it's just like stop sign. If someone try to replace, then it will not allow another threads to try to replace it. So that's why string buffer is recommended to use for like multi-threading programming. So you already understand the concept of multi-threading programming, correct? Like if you program on your PC, then that's not multi-thread, right? Only one user using it. But if you program on the web environment, so that's multi-thread, because most likely a lot of users can access the web at the same time to your application. Web application should be multi-thread programming, correct? Right, string buffer is if use string buffer if the class might be accessed by multiple tasks concurrent. But multiple tasks not only for the web but also for the like client and server programming, like when you go to the restaurant point of sale system, they're gonna have many computer machines, right, that try to put in the order, right? So that's also the same thing, because they have one server that try to take all the data and all other client machines try to update. Like if I update the name of the item or update the price from one machine, it should update everything. Then string buffer should be used instead, right? Otherwise name will not be changed, right? Or we have a problem with that. Because it could be crash if two servers try to update the name at the same time. All right, so and also some of the method that you need to know is like capacity, because you may see those on the test too. Like I want you to go back and try to pick questions from this class exercise to do as your homework, and make sure that you are able to test all the methods here. Either prepare yourself for the test. Okay. Because these are the methods that may be very interesting. Like if I do dot capacity here, like for example, if I go back to my class here, I could just print the capacity. What's that, right? So it's technically it returns the capacity of the string builder. Okay, so what is the capacity of the string builder? So if you really think about, if you have to, like in the old time programming, like C, they don't have string. They only have char. We have char is, you already know that if it's ASCII, it's about what, 1 byte, and it's represent 1 characters. But we already know array, right? Array. Then in C, they pretty much just create a stream of characters. Those are string. But they don't call string, they just call an array of characters. Right? Correct? And then you have just index 0, 1, 2, 3, just exactly the same. That is per the string. So that's the old time programming, but Java just make it so easy with the object instead, right? Object. Now, if I want to look at the capacity, that's why, since it is an array, you guys know what's an array, right? You must define the size. Just like when I create my stack, you see that I have to define the size has to be at least 10. That is my capacity right there, right? But in the book, they try to make a constructor and give default size to 16 capacity, right? So same thing. When first time that, okay, let's see, if I just create a string without the size string builder, I want to get the capacity. let's see what do we get. And it's very interesting that they like to pick 16. Just like the same as the book that says 16 as a size. 16, like you could have 16 array of characters. 16 is a size, something like that, right? When you get more than 16, then it's going to update the size, just like the way that they implemented for the stack that I showed you earlier. Right, it's going to dynamically increases the size based on the string values that you have. Questions?
And how is it different from the length of the string?
Length? Oh, it's not. Length is the length. Size is actually, we look at capacity, right? The capacity, like the size of the array. Length is the length of the letters, which is different than capacity. Just like an array, I define 10, I don't have to use up to 10. Correct? If my array size 10, you talk about the size of array is like length, which no, the size of array is the capacity, right? Like now, my length of this is what? 3, but the capacity is 16 because I define more like an array, right? But I don't have to use up, right? Like now, it's actually by design, it's add those 3 to the size, to the capacity, make it 19, right? Right, when we look at this. So let's see if I do a. Okay, let's just add one more. So that's why on the test, if we do that capacity, you should know that 16 as the initial capacity, and then start to add based on the size of your characters, right? Like this one, I have the length of 15, my string is add to 16 to come to 31. So that is just some interesting thing about the method here. And then you can trim to size, reduce the storage sizes used for the string builder. Like now, if I want to trim to size, so it's going to, instead of adding it, it's actually try to save the spaces, right? Otherwise, those array declare you wasting spaces. So it's just trim to the actual size right away of your string. Right, so this pretty much just save the spaces. Since first time you declare big because you don't know how many you're going to store, and then since you already know, then you can just trim to the size to save the spaces, the memory spaces. And that's pretty much it for string builder, string buffer. I mean, the rest of the methods, I guess you technically can tell, like insert, right? Char add, length, delete, char add the index, it can delete. You could delete, insert between with a whole new string, right, into that index location. You could replace, you could do reverts, you could do substring, and that's pretty much it for